Okay, I'm going to finish up today's lesson. We didn't get as far in 7th period as we did in 6th, so I'm going to add on that and then add on a little bit on half-life. All right, compound interest formula is this formula. Because our calculators are very adept at understanding order of operations, when we enter this, you can enter it as this: P, which is the principal, 1 plus your rate divided by the number of time periods, number of times it's compounded per year, raised to the, and you can just hit the raised to the button and it should be up here in T, should stay, oops, let's see if I get that back, stay in the exponent and you should be fine. So P is going to represent our principal, that's our starting investment, our starting amount. R represents our annual interest rate written as a decimal. N is the number of times the interest is compounded per year. T is time in years, and A is the total amount after T years. When we're looking at compound interest, time occurs how often? Well, annually means once a year, biannually, twice a year, quarterly, 4 times a year, monthly, 12 times a year, weekly, 52 times a year, daily, 365 times a year. So if we were going to take and evaluate for this situation, find the final amount if a $500 investment after 8 years, 7% is compounded, and these are our different ways. So what we would do is we would start off, our initial investment is $500, our interest rate is 7%. That's ridiculously high for current days. N is how many times it's compounded, and we're doing it for 8 years, so T is time in years. So this N is going to change. For annually, I'd plug in 1 here, where I have N here and here. For quarterly, I would plug in 4 here or here. Monthly, I would plug in 12 here or here. And daily, I would plug in 365 here and here. And when you determine these, when you plug in 1, we would get annually, our answer would be $859.09. Quarterly, our answer would be $871, so slightly more, and 11 cents. Monthly, our answer would be $873.91, and then daily, when we plugged it in, we would get $875.29. So this shows us the more times the interest is compounded, the greater our outcome will be. Now, compounding means when our interest is left in the account, added to the account, and the interest earns interest. So the interest that you earn continues to earn more and more. So the more times we compound it, the more times we add back that interest. Annually means we only add back that interest once a year. Quarterly means 4 different times a year we find the interest, add it back, and then that interest earns interest. 12 times a year is what would happen on monthly. 12 times a year our interest would be added back. And then 365 would be every day. So there's some for you to try, and on the notes I'll have the answers to those if you want to go ahead and try those. Now, I also wanted to talk to you guys about half-life. Well, when we think half-life, what we're talking about is how long it takes for half of a material to be left after it decomposes. And it doesn't always have to be a radioactive material, but here we have the half-life of radium-226. And the half-life of this particular element is 1,620 years. So if we start with an amount, it would take this long for half of that to be remaining. So what would the half-life look like? What would the equation look like? Well, it would look like this. The total amount remaining after a given time is equivalent to whatever the initial amount was, the amount at time 0, whatever the initial amount was, and its half-life, so my multiplier is a half. Well, now this half-life occurs every 1,620 years. So we would take whatever our number of years is and divide it by 1,620 to see how many times we would do half. So let's plug in the pertinent information here for B. Suppose a 20-gram sample is sealed in a box. Find the mass remaining after 5,000 years. So we want the amount remaining after 5,000 years is equal to the initial amount, which is 20 grams. Its half-life. So I'll do 1/2 raised to the, we're leaving it in there 5,000 years. But how many times is that? If my half-life is 1,620, well, you'd take that 5,000 and divide by 1,620. Okay, and that would give us approximately 2.35 grams remaining. Okay, when will this be a fourth of its original amount? So, no matter what the original amount was, let's say it was 20. What is a fourth of 20? So we want 5 grams remaining because 1/4 of 20 is 5. You're going to see something interesting happen in just a second. Now when we're solving this, we have to get rid of anything extra, which for us would be divide by 20. And what is 5 divided by 20? That is 1/4. Was that 1/4 something I should have been expecting to happen? It is, because my instructions asked me to find when 1/4 is remaining. So if we just were to pick an amount and take a fourth of it, when we divide by this, every time we'd be left with a fourth. Now you might be saying, ooh, how do I solve for this exponent? But you know how. We can write 1/4 and 1/2 with like bases. 1/4 is 2 to the negative second. 1/2 is 2 to the negative first. And now once we have like bases, we can set the exponents equal to each other. -2 is equal to -x divided by 1620. So if I multiply both sides by a -1620, I get that x is equal to 3,240 years. So that's how long it would take us to be down to a fourth. Okay, when will the 20-gram sample be completely gone? Well, if every time we're taking half, can we continue to take half and ever get to 0? Never. We will never get to 0. There will always be at least a trace remaining. So I've saved some examples that I'll put on the notes, but I'm not going to go over those now. But hopefully this will help. Thanks.